if you can do the calculation of embeddings after data insertion, that means that other applications which don't necessarily have the same environment as you, such as front-end applications or other database users, can insert the data, and then you can separate that from the actual computation, the embeddings. And that's a theme that we kind of generalize to the maximum. So in principle, data could come into your data deployment from any source, and then we have a way to kind of watch the database and compute these embeddings, or it doesn't need to be embeddings, let's be clear. This is about more general AI. So this could also be classifications, that these react to incoming data. And that has many very nice upsides for application developers. Like data is always up to date with inference points, so vectors or predictions. So if you're doing search, for instance, that's great because then you get real-time search of incoming data.
Hey buddy, welcome back to another episode of How AI is Built. Today we have a very special guest. Duncan Blythe is the CTO and co-founder of SuperDuperDB. If you have nightmares from deploying AI in your data stack, or you're just tired of defining data loaders and data ingress after you run a simple classification, stick along. SuperDuperDB is bringing AI to your database, enabling you to easily apply AI process directly to the data in your data store.
SuperDB is an environment for deploying and fine-tuning AI, training AI together with your data store database. So the idea is that your data lives in your database, in your application scenario, and you often want to connect AI functionality with that. So the most obvious example of that would be semantic vector search or question answering. And the standard way of approaching that problem is to sort of extract data from your data store, ingest it into infrastructure, maybe onto AWS or other cloud providers, into other infrastructure, essentially different from your data store, and then using some kind of sequence of ETL pipelines, transform the data into the form you need to get it into a model that will then implement your AI. And then once the AI is finished, it's got more data coming out of it, and then somehow needs to get back into your database. So it all starts and ends with your database. But in between, at least in the status quo of 2024, there's a lot of manual work and infrastructure work that developers need to do. And wouldn't it be nice if you could just define which data you want your AI to somehow work with in your database, then for your system to work, just simply work. And the problem with that is there's a lot of simplification implicit in that process. So if you do provide a technology which does that, which makes things work, then you're going to be making probably gross simplifications which aren't going to work for the majority of developers, especially as you start to go to bigger organizations. So instead of just providing an application that can do that kind of thing, we provide a framework that allows you to configure those kind of processes, which essentially apply AI directly to data in a data store and work in close combination with your data deployment, but where the details of this workflow are very much open to you as a developer. And so it's an open source package and everything's kind of transparent and you can define your own models and workflows. Yes.
Yeah, and especially as you're building data pipelines right now. So what I struggle with really in my data storage is when do I best calculate the embeddings? Because often when you're having a data collection, you're batching it or you even do it real time. And you really have to decide like when is the optimal point to do it. And what I was actually looking for when I found SuperDuperDB was a way to actually do it after the insertion, basically in the database, or when I go to the database, to have it synced up in a better way where I can react better to the, for example, amount of data I actually have and also when it's coming in exactly.
Yeah, right. So there's some good points there. So you've talked about keeping things up to date. The first point you made is a pretty subtle point, which can be hard to appreciate. But if you can do the calculation of embeddings after data insertion, that means that other applications which don't necessarily have the same environment as you, such as front-end applications or other database users, can insert the data, and then you can separate that from the actual computation, the embeddings. And that's a theme that we kind of generalize to the maximum. So in principle, data could come into your data deployment from any source, and then we have a way to kind of watch the database and compute these embeddings, or it doesn't need to be embeddings, let's be clear. This is about more general AI. So this could also be classifications, that these react to incoming data. And that has many very nice upsides for application developers. Like data is always up to date with inference points, so vectors or predictions. So if you're doing search, for instance, that's great because then you get real-time search of incoming data.
Yeah, and we have especially see like, for example, in a comparison for a vector store, just to continue with the example as LensDB, where you basically have to recompute the index, the embeddings every time the data is coming in, which this would streamline by a large amount because you actually have the new embeddings calculated instantly.
It's interesting that you mentioned LanceDB. So LanceDB is an extremely fast way and efficient way to actually compute the different similarity between the vectors. So they have this very nice embedded approach. But as you rightly say, so there's a lot more to it than just having the vectors pre-computed. That's the theme that you also see with LangChain as well. So LangChain and Llama Index, they have this idea that you have a retriever and that has the embeddings in it. But if you've actually ever built an application where you have some kind of information retrieval, updating the index is one of your main concerns. So we come from e-commerce. So in our previous startup, we built a search engine, which was deployed on many large websites. And there it was exactly this incrementals that you're really not struggling with, but a lot of the technology is around that. And that's why bringing AI and databases closer together makes a lot of sense, because a lot of the concerns that obviously database developers or engineers know about, but also engineers who are in areas such as search, where you might have extractors on the data as it comes in, like you do in Elasticsearch. And there's a much more general notion of pre-processing data points ready for AI that is kind of makes a lot of sense when you understand how it happens in these kind of information retrieval applications.
Yeah. And what my biggest pain point in LangChain actually is if you go into like more complex retrieval where you can have a hybrid search, for example, because you would have to refit your BM25 retriever, for example, who is doing a keyword search every time new data is coming in. And if you rather move towards like a vision where you are directly in the database and you can run a keyword extraction, you don't really have to worry about that because you can just put that into an additional column, which is indexed, and where you then can directly do a search or a filter.
Perfect, exactly. So you've got to the kind of core of the issue, which is in search. Just let's take search, but I think all concerns which apply to search actually apply to document QA as well. So this idea that you don't just want the answer as estimated by the LLM, you want the answer subject to many constraints. So for instance, if you're doing e-commerce or some kind of product navigation, you have to be able to implement business rules. And these business rules might look like something like, if the user enters a particular brand in their search, like Nike, they should only get results which are by Nike. So what does that mean? Suppose we try to solve that search with just vector search, no database technology or filtering technology. So then we would get the search, convert it into a vector, and find very similar things to my search. So maybe Nike Air trainers. And then what happens? Well, then we get a bunch of products from the database which are like your search, not exactly your search. So they maybe give you some other Nike trainers, which is fine. Then they might start saying, oh, well, there's this cool, the model might start thinking or inferring there's this other cool thing by Adidas, which is kind of similar to that. So let's return that as well. And then, the company who's hosting the search might even get some kind of financial penalty for returning this search result. So what you really need is a rule. And what's the rule? Well, the rule is very simple. You extract the brand from the search and filter the data, as well as searching for similar things to your thing. So you apply just a database query and somehow merge the results with the similar part. And you need databasing technology to do that.
And that especially allows like for much smarter search, as you see currently, especially in the vector database market like Pinecone, VV8, where you often are pretty much restricted to a similarity search, and that's it, and some filtering algorithm. And that's quite interesting to me as well. What really popped out that you mainly focus rather on the more or older storage technologies, especially like MySQL, MongoDB, and Postgres, rather than going with any of the like newer providers. What was the decision behind that?
Right. So obviously you say old, but actually even MongoDB is like a pretty new company. Like it's 10 years old or something. But obviously the other databases have been around for absolute years. I mean, we've been in companies before where often the database, there's no negotiation. It's not like, hey, let's try a different one. Why? Because it's there already. The data's already in there. So you can say, let's try this Pinecone thing, but you're not going to like throw away your old database and put everything in Pinecone. It's going to stay. So at the very least, what you want to happen is to have some kind of sync operation between your database and not all of the data, but some of it to the other one. Well, then the other one is not really a database. It's just for doing the search because the actual original database, like Postgres or whatever, it has better database operations on it than the Pinecone. So maybe Pinecone allows you to filter with some tags or something, but it definitely doesn't allow you to do the thing which the original one can do. So you're basically using it for something which is only part of the functionality, but it's the real reason you're using it. You're using it as a place to store the vectors and to do the quick search. Then what happens when Postgres implements this PG vector plugin? What are you going to do? You're going to not use that, or in preference for this expensive Pinecone thing, which is not even open source? No, you take the plugin. We thought this would happen, and it really has happened now. So almost all the databases have some kind of vector search strategy. And for developers, that's great because they don't need to migrate their data. They don't need to add another piece of databasing technology. And like every database you add to your stack is a point of failure, which can be extremely annoying. And the question is, these new databases, although they might be able to execute searches quickly, do they have the kind of fail safes and the robustness that the standard database has? Well, probably not, because these companies, like, there's a reason these companies are so old, because it's a very difficult thing to implement and to grow a database company. So
Yeah, a friend of mine always says he's like a really big data guy, and he says like databases take 25 years to really mature, and after that you can consider them stable. And I think we reached it now with Postgres, which makes it a really great database for me at the moment as well. And one specific example I just had recently where I used Pinecone and then moved back to Postgres is datetime filtering. So I basically have timestamps, and in Pinecone, I had to use Unix timestamps to allow me the filtering I needed to restrict the search to the specific dataset. And in SuperDB, how did you go about, like, what's the easiest abstraction of how you actually work below the hood? Because like one of the main innovations was actually separating storage and compute and databases. And now it seems like you're basically bringing the compute back towards the database.
So the compute is not necessarily even running on the same server as the database. The Unity is more in the developer experience than in the actual underlying compute. So the idea is you would apply your model directly to a database query, essentially, or combine it with a database query. But that doesn't mean that the compute and the data, everything's on one server, although it could be. It depends what your operational requirements are. So for solo developers working on their local machine, maybe that makes sense. So we've built it in a way that's flexible enough so that you can make some decisions. So we support Array as a computation engine. So the vision is, so obviously if your compute's too far away from the data, then you have to pay for someone to drive a truck to your data storage and drive hard drives over to the compute. That's actually what sometimes happens. So obviously that's highly self-optimal. So you want to get the compute close to the data in a very fast network. So that's what we talk about when we're saying bring the AI to the data. But it's also like the developer should not have to write ETL pipelines and sync scripts to get things to work. Because those things, firstly, you're going to have to throw up other infrastructure to get them to run. And you're adding statefulness to your application, which is just inherently buggy. And so you don't want to have to write that stuff yourself. So that's what we mean when we say bring AI to a database. You just declaratively say, so you declare this model acts on this data. And then under the hood, this thing's working to compute your outputs and populate the database. And then you've got a much more robust deployment, a model which is very clear for developers how to get started.
Yeah, and this also gives the developer in the end the flexibility to actually decide like what is the restricting part in the AI, and also what is my workflow looking like? Am I streaming or am I batching? So do I have to actually have like fast computations where I'm in real time, where I'm more IO bound, so I have to be closer to the database? Or am I actually like CPU bound in the end, like where the computation takes most of the time, where it's like more rather a batch use case, where I can go in the end further away from the database and pick like a more powerful machine, and the latency in the communication to the database isn't the biggest factor in the end.
Right, exactly. So often there's sort of obsession with the speed of the computational scalability, but it's like these operational requirements can sometimes be much more important. So there's a trade-off between all the variables, and we want to make it possible for developers to choose their place easily with the framework without having to massively refactor everything. We actually have this separation not just between storage and compute, but also between development and infrastructure, which I think in AI has not been possible until now. So what does AI development usually look like? It usually looks like some mix of technologies where an AI developer who studied data science, they're starting things in the cloud, running bash scripts, pulling things in from here, writing a server somewhere, just struggling to even get started with the actual science because it's called data science. So it should be about the science part, but the science part is really the experimentation. That's the kind of essence of science. It shouldn't be about engineering. And how can you actually remove all of this infrastructure and boilerplate from this workflow? And it's to do with abstracting the data layer, essentially, and abstracting away from infrastructure in some clever way. For that, you can't just solve a piece of the puzzle. You can't say, I'm going to make starting an instance on EC2 easier. You can do that if you like. There were even companies like Paperspace. There was it Paperspace. It seems to sort of disappeared, but their model was like, hey, make it really easy to start an instance on the cloud or something like that. Anyway, so in the end, like you can solve one piece, but what we really want to do is just provide an environment where, in principle, like a statistician or just a data scientist who doesn't really know anything about the actual underlying compute can work with it and get good results.
Yeah, especially if I'm looking at data teams or AI teams, you usually always need like a data engineer, MLOps engineer who is also pretty good in cloud, and then you have the AI person or the data scientist to actually get work done and enable the data scientist basically to do his work. And this makes it like way easier and way faster, and doesn't require me spinning up a microservice every time I want to actually try my AI on my data.
Yeah, so like it's essentially like there's a lot of kind of sociology and weird practical stuff that has made the world the way it is in such a kind of suboptimal way. And this is like one example of that. How cloud compute has kind of come to cater for the needs of data scientists in like a very suboptimal way. Because like the cloud, it wasn't at all built for this stuff. I mean, just for instance, take the concept of like a job which runs just once, like a one-time job. So if you were a scientist and you worked in a university, there would be like a compute cluster and you would have a deploy script and you would deploy a script from your local via SSH or something, log in, and then it would run one time, and then the results of your job would be like saved on a shared file system on the compute cluster. So on the cloud, I just do not understand why that thing that I just described, why isn't there like a equivalent? And I guess it's because technologies like these containerization technologies like Kubernetes, they're catering to this concept of like we want to have a deployment which is always on, not it's on for a bit and then it's off. They're talking about like high availability and stuff, but that's not at all what my job is about. And then like the shared file system, it's like a very exotic case for these things where you have like an NFS file system across the whole thing. They just dump data into buckets, right? But that's terrible if you're trying to have high data throughput. Anyway.
Nice. Moving on a little bit more to the databases, because you roll actually all the integration into the different database management systems. What are the trade-offs of the different databases, and what would be, now that you've done all the work, what would be your decision tree as a developer to choose the right database for the job?
For AI applications?
Yeah.
I mean, you have sort of databases which are operational and databases which are analytical. That's the general bifurcation of things. And, operational databases are designed for like small reads and writes. So little deltas coming in. Whereas, these analytical are designed for big reads, right? So not designed for write. So that's the kind of classic dichotomy. And then there are databases which aren't really databases at all, and they're really just references to data hosted in S3 buckets or something. So these are more sort of data warehouses or data lakehouse managers or what have you. Those are another category. And I think so transactional databases like MongoDB, for the first time, they're good for these kind of AI applications, because initially AI was like this, there wasn't like a runtime system which had a data part until 2022 or 3. AI in production is just like an endpoint. So you pull your data out of your data warehouse or storage and you basically prepare it into some pre-processed format. And often that format is like numbers or something. So tensors. And then you run your training on that, and then you get a model, which is like something like in TensorFlow. So something that allows you to do predictions. So then you create a server, and when data comes in, it's just going through the server. So in a production case, the model might have like 10 things it can return, like 10 different labels. Or maybe like if it's a face detector, for instance, like two numbers, the top and the bottom of my face or something. But there's no like reference to an actual database, which means that for AI, you never wanted to have like an operational, so transactional database. But that's different now, because now in production, you want to have your model kind of deployed together with a database and executing searches, vector searches, plus some maybe hybrid searches like we were talking about earlier, and then pulling like a couple of rows out of the database and then serving it to the user. So now these kind of classical databases, which such as MongoDB, they're now interesting for AI. And there's another use case where a transactional database can actually be useful for AI development, and that's when you're training something that requires you to read a very small portion of your data in real time during the training process. So for instance, if you're training computer vision, a typical thing is that you cannot load all of the images at once because they're big, right? So you might have 1 million images. So your model continuously goes through the data. Maybe it loads it 100 times in the course of training. Every subset of data, it will load like a bunch of images. And you can do that from a fast file system, but then you need to kind of know which images to load, and you could prepare some data. Or another thing you could do is have a database which allows you to kind of manage that process. So that's another use for transactional database. And then these other solutions, maybe you want to do some kind of analytics on your data. So obviously that's, as it was before and it is now, it's still a very important task. Like, what is going on in my organization, for instance? Like, tell me how many users are clicking on this website. So what does that query look like? That looks like so that's an analytical operation. An analytical operation, you're kind of going through more than just a couple of rows of your data. And for that, now AI is also there, because I want my AI to help me create those queries, because like maybe I don't know how to make that query, but I know how to ask questions. So then you kind of want to pair your AI model with something that can actually execute the query. And so then you're bringing AI to your analytical database. And now we go to kind of warehouses, lake houses, where you have actually massive dump data which are tracked by your data lakehouse warehouse. The reason why you have that is that data is kind of streaming in from somewhere, maybe from the whole company, just going, everything we have, we're just piling it into something like Snowflake. And Snowflake's like the end location of my data. And the question is not like, tell me about these customers. The question is just like, what do I even have? And so there also AI is going to be useful. Okay, so I'm not exactly answering a question which database I should take. I'm answering like an adjacent question, which is in which situations is AI useful for which databases?
Which is even the better answer.
Yeah.
And what's challenging nowadays for me in the especially rag use case where I'm doing some search and then I'm doing a generation is actually the experimentation with the texts. So basically with the chunks I have in the database and the vectors, because it's very laborious to basically adjust that over time. And when I also have already have a large amount of data in there, how I adjust my data to basically go with a different chunking strategy. Because at the moment, I'm always forced to go back to my original data, implement the new chunking, chunk the documents anew, and then basically embed them and reinsert them into the database. I would be really curious whether you see in the future a better way to handle that, maybe even directly in the database.
Right, so that's an actually use case that we solved. So it's not inbuilt support for that because that's not really the philosophy. The philosophy is to give you the tools you need to solve that kind of problem. But we've got all the bits and pieces, and I can tell you what a solution would roughly look like. So let's just take the situation where you're starting and you don't have anything. So you have your data maybe in a PDF form, and you want to kind of make it searchable. So you need several steps. One is to extract the data into text and then map it into these chunks, put the chunks in the database, then run a model over these chunks, save those vectors, and then you have the end model, which is configured to search through those chunks with vector search and then ingest the chunks as chunks or other chunks which might be related to those chunks. So let's not forget about that. Ingest them as kind of a prompt for this language model. So what does it look like in SuperDuperDB? What in SuperDuperDB you do is you set up 3 models, but one of these models is not really a model in like the AI sense, but let's just call it a model, a function maybe. So the first one is, and there's a previous step, which is to define a data type. So data type is like, I'm going to define my own data type called text PDF. And the text PDF data type is a thing that understands that when I insert a URL or an S3 URI of a file, it should kick into action, pull that data onto the local file system and refer to it, or actually insert the file as a raw blob, depending on my operational constraints, into the data deployment. And that's going to be tracked from your database. So that's kind of, I can literally insert PDFs into the database as though I was inserting rows of text, but I'm not inserting rows of text, I'm inserting actual files. Step 2, you just set up a small model type thing, which is opening these PDFs from their storage location and inserting these chunks into the database. And the third step is to configure a model to ingest those chunks and turn them into vectors. And then the final step is to connect that final model with the open AI or self-hosted LLM, registering the fact that it should somehow connect with these chunks. Right, so like I said, lots of complexity, lots of possibilities, so many ways to configure the system. And the good thing with SuperDuperDB is that the sequence of how you do this doesn't even matter. You just kind of declare it. This is how I'm doing it. I say, here's my data type, here's my mapping collection with the model that maps it there, which has a chunk size as a parameter. Here's my embedding model, here's my chat model. These things can all be versions. So if I decide I don't like it, I could just update the version, and under the hood, the whole thing would realize it's not up to date and re-implement and recalculate all of those parts in between. And that's kind of the beauty, is that I can quickly swap out, for instance, chunk size in a new version, and then the system will kick into action. If I like, I can deprecate the old one, and the new one would just calculate new stuff, or I could keep both side by side and even compare them in their quality. So obviously you get more data, but the vectors are pretty small and the chunks are pretty small. So yeah.
So we basically are looking at a Terraform for AI at the databases where I just have to declare what I want.
Declarative machine learning in production as a declaration. And we even have a YAML formalism, which is still in private, except it's not private, it's just we haven't talked about it yet, where I say, here is JSON or YAML declaration of what models there are. And you say, I want to apply this to that data. And SuperDuperDB is basically going to do the work. And it goes further than that, because one declaration could be, I declare this model and it's going to act on that data and have as training data, this data. And so what does it mean? Under the hood, it knows that the first thing it should do before it becomes available is to train itself. So training and deployment in one thing as a declaration.
Well, that's actually crazy to me because at the moment I'm looking more and more at like more recommendation system use cases, especially in LLMs. They are so prevalent because everything RAG in the end is also a recommendation system. And also as in LLMs, I see more and more of the compute shifting towards inference so that I calculate multiple different options and then I have to pick the best one again. So this is a recommendation as well. And this seems like a really like SuperDuperDB also really tailored to some things I really have to do in recommendation systems.
Okay, do you mean that the model should even recommend which model to use in the next step? Or what do you mean? Are you just talking about recommendation systems? I understand under kind of this user should use this product or buy this product.
That's for one, like the feature calculation in the end in real time, where I have to calculate many embeddings on new user interactions that are coming in. But also for one, where I have like in text, for example, that's my use case where I generate a new text, but I generate multiple different texts, which might come from different prompts or even different fine-tuned models. And then I pick the best one of those texts.
Oh, I see. That's also great. So with LangChain, would you say LangChain provides that functionality?
No. So basically, that's what
So I
we.
would like to make a short advertisement. So also in version 0.2, we have Graph Theoretic Model Builder API, which allows you to combine any directed acyclic graph system of models into a single model. So it's like a multi-level model building framework. These models can include LLMs, but they could also include like a vector search call. So we're going to a level of abstraction where all of these things kind of belong together, and we're staying in this kind of dot predict world. So in graph land, a model which implements a vector search, when you call dot predict on that model, it actually executes a search. So then you bring the database API into your model workflow, and that can allow you then to do all sorts of novel things. And exactly the other thing would be maybe you have some kind of switch that toggles between models.
That's great. I'm really curious. What are you using for the DAX below the hood?
This is just initially a very naive implementation in Networks X, but we're also deploying models on Ray, which has support for interdependent models. So the hope is then to actually deploy the models potentially with their own environment. So you get the benefits of that scalability. And then you would have a thin wrapper on top, which is essentially sending the requests off to those models.
Yeah, so none of the like more common data engineering DAX like Airflow, Dexter.
No, because I think these are more like for batch jobs generally. I think, yeah.
Okay, great. So what's next for SuperDuperDB?
This project, exactly 0.2.0, we're releasing our Ray implementation. We're also releasing deepened support for self-hosting your own models, especially LLM models. So recent developments, more smaller LLMs are out there. So we had the Gemma models released yesterday, 2 billion parameter models, which can perform quite well. So all of that means that everything's going back to like client side, have the model yourself, or not client side, but host it yourself. So we want to deepen our support for that. So competitors such as MindSDB, they're more in the realm of sending API requests to other services. So we really want our developers and organizations to own their whole stack. So that's one aspect. Another aspect is exactly the more support for more flexible range of models, as I described. So it's Graph API and just generally trying to make it easier for developers to contribute. So we've got lots of interest, but not many contributors yet, which is a shame because I think it's a very exciting project to contribute to. And there are different aspects of the project which could bring in different types of developers. So we're definitely interested to encourage developers to take part.
Where would be the easiest way for people to actually get started with SuperDB and also get started contributing? Like, what are the most pressing issues at the moment you're looking at?
So in contributors, so just getting started, we have some docs there. We're building those out also to be more comprehensive for V0.2. So please start in the docs and also look at our use cases, which each have their own notebook. That's one thing. Then you can also look through the code, look at our issues. So we'll have some good first issues. And the easiest places to contribute to are sort of model frameworks that you'd like to see implemented. And for that, we have a pretty clear path for an interested developer. The more difficult part is adding new data deployments. So we're trying to simplify that as much as possible, but it's still early days. So those are the two, AI and data, the two big areas to contribute.
Great. Do you have anything else to shout out what people should follow or where people should follow you and SuperDuperDB?
Yeah, so we're in the process of building the managed service, and that is going to be on-prem, hosted, or cloud service. There'll be two versions. We're also building a service which runs directly on Snowflake. So if you have a Snowflake deployment, you can, when we're ready, deploy that directly on your data there. So we have a waitlist on our website. So if you're interested in being involved in that, you're welcome to send us a request on the waitlist. And that will be nice because that will come with the front end, which will allow users to view the system from a higher level and to get this kind of control that they might not necessarily get fully on the open source side.
And we will link to all of that in the show notes.
Thanks.